This is linear second order equations, and in this section we will be talking about non-homogeneous equations and using the method of undetermined coefficients to find a particular solution. So as you can see, we have a linear DE, we have constant coefficients, of course, this is non-homogeneous. And we have f of t is a single term. Now, this single term will be a special form, and we'll be talking about that through this entire video. So we will also be guessing solutions. And then we will be looking for some patterns. Also in this section, we will be finding particular solutions, not an infinite, not a general solution with infinitely many solutions. So we will seek particular solutions. And why don't I change this and say seeking A? Okay, so let's go ahead and take a look at this first form of f of t. And here we have f of t as a constant times t to a power. And our power can be 0, 1, 2, whatever that might be. And we are going to guess our solution. So I'm just going to go ahead and write guess. This is going to be a guess, a solution of this form. Now, as you can see, we will include all descending powers all the way down to the constant. So it's really important. So even if this is just a t cubed, we will have t cubed, a t squared term all the way down to our constant a naught. So let's look at our first example. Find a particular solution here to y double prime plus 3y prime plus 2y equals 3t. So here we are going to go ahead and guess our solution as y of p. And we are going to guess that solution as a times t plus b. So we will need that constant term. This is what we have, and t is equal to 1. Okay, so going ahead and finding our derivatives, we have y p of t prime, and that's going to be equal to a, and then we have y double prime, and that's going to be equal to 0. So going ahead and plugging these into our given differential equation, and we will have 0, of course, plus 3a plus 2 times at plus b is equal to 3t. So we have 3a plus 2at plus 2b equals 3t. And as you can see here, we have 2at plus, we'll go ahead and put those constants together. So of course we have to have 3 is equal to 2a. So a is equal to 3/2. We also have that for our 0, we also have that 3a plus 2b is equal to 0. And now that we have a is equal to 3/2, and we can go ahead and take a few minutes to come up with that, but we will get a negative 9/4. Let me go ahead and come up with that. So with that, we now come up with our solution as that particular solution is 3/2 t minus 9/4. Whoops. Okay, let's look at another type. So this one was a constant times t to a power. And now you can see we have our exponential term here. So now we have f of t equals to a constant times c, a constant times e to a constant times t power. And so this is our f of t. And we are going to guess a solution of this form. So let's see what we can come up with in this example. So if we go ahead and let that particular, we'll guess that particular solution to be a e to the rt, and a e to the 3t. And now we'll go ahead and come up with our derivatives. And that will be 3a e to the 3t and 9a e to the 3t. If we go ahead and place those guesses into our differential equation, we can come up with 9a e to the 3t plus 3 times 3a to the 3t e to the 3t plus 2a e to the 3t equals 10e to the 3t. And here we can go ahead and factor out an e to the 3t, and we would come up with 9a plus 9a plus 2a. So it must be that 20a is equal to 10 and a is equal to 1/2. Therefore, our solution is equal to 1/2 e to the 3t. Let's look at our next form of f of t. And as you can see here on the right-hand side, f of t is either going to be c times the sine of beta t or c multiplied by the cosine of beta t. Again, keep in mind, f of t is a single term, so we cannot have both of those terms, and our guess is going to be a multiplied by cosine beta t plus b multiplied by sine of beta t. So let's go ahead and see how that will work in our next example. So we are given y double prime plus 3y prime plus 2y is equal to the sine of t. Using our guess, or this form above, of y of p is equal to a cosine. And I'll go ahead and write sine first. We can use either a multiplied by the sine of t plus b cosine of t. And we'll go ahead and get our first derivative, a cosine of t minus b sine of t. And of course, our second derivative would be the opposite of a sine of t minus b cosine of t. Now, if we go ahead and place those into our given differential equation, you can see that we have the opposite of a sine of t minus b cosine of t plus 3a cosine of t minus b sine of t plus 2a sine of t plus b cosine of t is equal to the sine of t. So let's go ahead and gather our sine of t coefficients. So if we have the opposite of A minus 3B plus 2A, and that's multiplied by the sine of t. And then we have for the cosine of t, we will have the opposite of B plus 3A plus 2B. Oops. And that's equal to the sine of t. So simplifying this, we have A minus 3B multiplied by the sine of t. And then we have plus B plus 3A multiplied by the cosine of t equal to the sine of t. So as you can see, we have A minus 3B must be equal to 1. So A is equal to 3B. And then we also have that B plus 3A has to equal 0. And so B plus 3 times 3B equals 0. So that would be 10B is equal to 0. And I think I made just a little mistake here. Let's just go back and look at this. This is that A is equal to 1 plus 3B. That's a little bit better. And so now we have B is equal to the opposite of 3A. It's kind of a mess. Let's redo that. So let's just do it like this. B plus 3 times 1 plus 3B. That's better. And of course we get 10B equal to negative 3. And of course we get B equal to negative 3/10. So therefore our solution is y of t is equal to, and we need to go back and figure out this A. So A is equal to 1 plus 3 times negative 3 over 10. And that will simplify A to be 1/10. So now we have 1/10 sine of t minus 3/10 cosine of t. Let's do that again. Okay, so this is really nice. We have a plan for each form of f of t. Our guesses seem to work because we came up with a particular solution. But what happens if our solution happens to be a solution to the associated homogeneous equation? Let's go and look at this example and see what might happen. So if we used y, and let's just call it y1, equal to ae to the 3t. Plugging into our differential equation, and let's go ahead and find y prime. We would have 9ae to the 3t minus 6 times 3ae to the 3t plus 9 AE to the 3t is equal to E to the 3t. So what happens here is that all of these terms on the left-hand side cancel, and we end up with 0 equal to E to the 3t. That can't happen. That is not equal to, let me use a different color. This cannot happen. This is not equal to that. So we need another guess. So what we're going to be doing is coming up with another power of t. So that would be yp of t equal to at e to the 3t. So let's give that one a try. So with that, we have yp of t, and I'll just go ahead and take that. We already know it's a function of t, equals at e to the 3t, and let's go ahead and get our y prime, and that's 2a. And actually, let me go ahead and just give this to you. If we use that particular solution with a factor of t, we end up with at e to the 3t, and that would be our second derivative of that function, minus 6 times at e to the 3t, first derivative of that, plus 9 multiplied by y sub p. And that is also going to come out to be equal to 0, and that is also not equal to e to the 3t. So we have to append or add another factor of t. Let me go ahead and write that here. And I should probably have written this with maybe a y2, because that was our second try. And then let's go ahead and call this yp, because I'm telling you that it is going to work. So now we are going to have at squared e to the 3t. And I'll go ahead and highlight that square. And so now when we go ahead and plug those in, and I will give you those derivatives. So yp is at squared e to the 3t. So yp prime is going to be 2at e to the 3t plus 3a t squared e to the 3t. And then y double prime is going to be 2a e to the 3t plus 12at e to the 3t plus 9at squared e to the 3t. So when we place those into our differential equation, we come up with 2ae to the 3t plus 12at e to the 3t plus 9at squared e to the 3t. And now we're going to subtract 6 from that first derivative, which is 2a t e to the 3t plus 3at squared e to the 3t. And now we add 9 multiplied by our y sub p. And we see that we have that equal to e to the 3t. And this will come out to 2a e to the 3t is equal to e to the 3t. So a is equal to 1/2. So that leads us to, and I'll just put that right under it. Whoops. That particular solution is equal to 1/2 t squared e to the 3t. Let's just see if I can make this just a bit smaller. Try that one more time. And just to have that up there. Okay, so now that is our particular solution. So adding that extra power of t. So let's go ahead and take a look at this summary. So what we have here is that if we have a constant t to a power, e to the RT power, and it can be of any form of that product, we will go ahead and have t to the power of s. And here is what we're going to have for our three cases of s. S will be equal to 0, so we'll just be using t only. If r is not a root of the associated auxiliary equation. Now, if r is a simple root, we will use s equal to 1. And if it is a double root, we will use s equal to 2. So we'll have that extra power of t. Okay? We will still have our full constant times t to that power going all the way to the constant. Now taking a look at these other forms of f of t. So if we would have either the cosine or the sine multiplied by these same constants and exponential, we will use this form noted below. Again, we have this power of s, and we will use those noted below. S will be 0 if alpha plus I beta is not a root of the associated auxiliary equation, and s is equal to 1 if it is a root, if alpha plus I beta is. Okay, so now in this next example, we're going to find the form only. We're only going to find the form, and we're not going to evaluate the coefficients. So for each one of these are f of t. So all of those a through f. So if f of t was equal to 7 cosine of 3t, what would we use for the form of our particular solution? The first thing I want to note is that this is supposed to be a plus, not an equal sign. And the second thing is I want to talk about the auxiliary equation for the homogeneous. And so that would be r squared plus 2r minus 3 is equal to 0. And here, of course, we have r minus 1, r plus 3 is equal to 0. So we have r1 is equal to 1 and r2 is equal to negative 3. So for A, B, and C, we can see that there are complex roots associated with them because of these trig factors. So we do not have any forms of these solutions there. So we will just proceed with our form. We would have y p of t of the form A cosine 3t plus b sine of 3t. Likewise, for part B of this form, we would have a1 t plus a sub 0, there's our constant, e to the t, cosine of t, plus, and here's our b1, our linear, plus b naught, e to the t, sine of t. Okay, and now looking at C also, which does not have an association with those roots, we have yp of t, and now we have this squared term, so we will have a sub 2, let me move this over here, t squared plus a sub 1t plus a naught, and that's multiplied by the cosine of pi t plus, and the same thing for b, b2t squared plus b1t, and I'll go ahead and write that on the next line. Multiplied by the sine of pi t. Okay, so that's for A, B, and C. Now, let's go ahead and look at D. Since -3 is a simple root of the auxiliary equation, we are going to, and let's go ahead and highlight that. Here's that -3, and here's that -3. We are going to have to take our particular solution of the form a multiplied by t, e to the -3t. And for e, we will have to do the same thing. We will have y p of t is equal to t multiplied by a1 times t plus a naught. And then we will have that multiplied by e to the t. Now, for f, because we have that 1 here with our 1 here, we will have yp of t is equal to t multiplied by a sub 2 t squared plus a sub 1t plus a naught multiplied by e to the t. Okay, let's go ahead and find the form of a particular solution to this equation, taking a look closely at f of t here. We will look at our homogeneous equation. And of course, we have r squared minus 2r minus 3. And actually, I want to make a little change here. I want to change this to a 2y. That's what I meant to have there, 5t e to the t, yes. So what we have here is plus 2. Let's go ahead and fix that, is equal to 0. And our corresponding roots are r1 is equal to 1 plus I, and r2 is 1 minus I. Now, since the non-homogeneity equation, the non-homogeneous equation involves e to the alpha t, you can see here cosine of t And so we have a beta t, and here we have alpha equals 1 and beta equal to 1. We must now use a solution here when s, right here, s is going to be equal to 1 if we already have that root. So we will have to have our t on the outside here. And so we will have y p of t is equal to t a sub 1t plus a naught e to the t cosine of t. And now we will have t multiplied by b1, b sub 1t plus b naught e to the t sine of t. So we will just have to take a look at those roots of our homogeneous equations, and we will have to use that extra form. Let's go ahead and take a look at this next example. And so it asks us here whether the method of undetermined coefficients can be applied to find a particular solution. So can we apply this method to these four equations? Looking at our first one here, we see that since t to the negative 1 factor t to the negative 1 is not a polynomial, we cannot use the method. I did want to go back and talk about here on the right side of this summary here. So this is really important. So we will be using this method when that non-homogeneous term f of t is exponential, polynomial, the sine function, and also cosines. Okay, so they can be any of these, or products. So we need to have just those four types. And so in this first case, we do not have a polynomial. Taking a look at this second example, we can see here that we can write f of t. Take a look at this. We can say that the sine of x divided by e to the 4x is equal to e to the negative 4x multiplied by the sine of x. So it is of the form, so yes, we can use the method. So we have an exponential, and we also have a sine function. Okay. So our method can be applied. Let's go ahead and take a look at this third example. Since the secant of theta is equal to 1 divided by the cosine of theta, we cannot use the method. We do not have that form. It's not an exponential, sine or cosine or a polynomial. Taking a look at our next example, we can see that we can factor out a 4x, and that's equal to 4x multiplied by the sine squared plus the cosine squared, which is just equal to 4x. So yes, we can use the method since we have a polynomial. Okay, let's take a look at this last example, and here we have a higher order equation, and we are going to be using our method of undetermined coefficients. Here you can see that r is equal to 1. So if we look at the auxiliary equation, we can see that we have r cubed plus r squared minus 2 is equal to 0. And we have r minus 1 multiplied by r squared plus 2r plus 2 equal to 0. And you can see that r equal to 1 is a simple root. And so, because we have that, we now have to use the form s equal to 1. Let's see, use form with s equal to 1. So let's go ahead and give that a try. Okay. So we will go ahead and have yp of t equal to t multiplied by a sub 1t plus a naught e to the t. And that actually comes out to, let's simplify that as a sub 1t squared plus a naught t multiplied by e to the t. So let's take a look at our derivatives. I have them just simplified here in a little bit different form. So we have a sub 1 t squared plus, and now let's go ahead and have our coefficient of t all multiplied by e to the t power. We'll go ahead and have the second derivative, and we'll need to go all the way to the third derivative, and we have a sub 1 t squared plus 4a sub 1 plus a naught t plus 2a sub 1 plus 2a naught e to the t. Then I will need an extra parenthesis, so I probably should have used brackets here. Okay, and let's go ahead and take our third derivative, and we have a sub 1t squared plus 6a sub 1 plus a naught t plus 6a sub 1 plus 3a naught, multiplied by e to the t. Let's go ahead and put those into our differential equation. And as you can see, we will have, and I've just kind of summarized here, I'll go ahead and rewrite that. So that this is simplified, 10a sub 1t plus 8a sub 1 plus 5a naught, all multiplied by e to the t is equal to t e to the t. So what we find here is that 10a sub 1 is equal to 1, and 8a sub 1 plus 5a naught is equal to 0. So we come up with a sub 1 is equal to 1/10, and a naught is equal to negative 8, negative 8a sub 1 over 5, which is equal to negative 4 over 25. So all of this leads to our particular solution, 1/10 t squared minus 4/25 t, all multiplied by e to the t. Okay, and that concludes this video.